Page 2, 1A. What is chemistry? Our world is full of significant problems like malaria, contaminated drinking water, and pollution that need answers. Other problems are more a matter of convenience, like developing alternative fuels for our cars, making smaller and more lightweight computers, and increasing crop production. Chemistry can enable us to solve all these real-world problems. But what is chemistry? Chemistry is the study of matter and the changes it undergoes. Matter is anything that takes up space and has mass. You are sitting on chemicals, using chemicals, wearing chemicals, and eating chemicals all the time. This just shows you the scope and impact chemistry can have on you for life. Christians can get excited about using chemistry to solve human problems like malaria. The Bible gives us a distinct worldview, a perspective from which to see and interpret all of life. Your worldview is made up of what you believe about the most important things in life. Like a pair of glasses, the Bible brings every part of the world into focus, including chemistry. 1.2. Chemistry as modeling. Chemistry is all about modeling. Chemistry, like all other areas of science, relies on our observations of the world. But we are limited in our ability to observe and to relate and explain what we observe. To understand complicated things about the world, we sometimes have to simplify the problems by leaving some information out. This means that an explanation of something can never give us the whole picture. Scientists have created models for every area of science. A model simplifies something in the world to explain, describe, or represent it. People make models all the time to predict where hurricanes will go, how an acid and base will react when mixed, and how climate will behave. Scientific knowledge is really useful in the framework of an explanatory model. Richard Feynman, physicist and Nobel Prize recipient, said, "What I cannot create, I do not understand." He also said, "Scientific knowledge is a body of statements of varying degrees of certainty. Some most unsure, some nearly sure, but none absolutely certain." Now we scientists are used to this, and we take it for granted that it is perfectly consistent to be unsure, that it is possible to live and not know. Feynman summed up an important aspect of science. Science is not about establishing what is true, it is about producing workable models. Only God's Word can tell us what is true. So how are scientific models useful? Models are essential to solving problems in the world for two reasons. First, they are workable. They help us make sense of data. Second, they have predictive power. They can help us see what could happen in the future. Models like the atomic model are the foundations of modern chemistry. Feynman used the atomic model when he participated in the Manhattan Project, the secret program that developed the atomic bomb. Also, his use of models demonstrated and helped solve the cause of the tragic explosion of the Challenger space shuttle. Models and worldview. Scientists use the models they create within their worldviews. Many scientific models fit within a biblical worldview, but some do not. Some scientists create and promote models that describe the world in ways that do not agree with the Bible. They even try to use their models to show that the Bible is not true. For example, the Big Bang Theory suggests that all matter in the universe is the result of random process. People who believe the Bible cannot accept this because the Bible traces the origin of all matter to God's special creation by His direct word. Scientists with a biblical worldview, on the other hand, try to create models that accurately model the world and are also faithful to the Bible. An example of this is the catastrophic plate tectonics model, which models how the Earth's surface changed very quickly after the flood. Chemists throughout history have developed and refined models that we use now to understand matter and the changes it undergoes. Without useful models, scientists are powerless to understand the world and solve problems that really matter, like the malaria epidemic that is snuffling out millions of young lives. 1.3. Chemistry and history. Chemistry developed over time for pure practicality. People needed clothing, food, tools, and medicine to make life easier in a world full of discomfort and disease. However, people have not always viewed and studied chemistry the way we do now. They had very different ideas about the nature of matter and the changes it undergoes. Ancient chemistry. The Bible mentions that even as early as 5 generations after Cain, men began to work with metals. Joseph Egypt had a culture that understood and used the medicines of early pharmacists called Phaceres. By these early chemists viewed matter differently. The Greeks philosophized and reasoned about the nature of matter. They connected temperature and the gaseous liquid or solid state of substance to soil, air, fire, and water. Eventually, the idea that matter was made of atoms rose from this Greek culture, but the Greeks never made it to the laboratory. Their only experiments were in their minds. The alchemist. The alchemist went to the lab. Ancient chemistry practiced by the Egyptians, Romans, Arabs, and even Europeans included a strong element of superstition, but was also robustly scientific. This culture of chemistry was called alchemy. During the time of the alchemists, astrology and mysticism were mixed with valuable observation and the beginnings of a rich legacy of experimentation. They searched for immortality through medicines, tried to change common metals to gold, and experimented to discover the nature of the elements. They even developed secret languages to encode their recipes for different concoctions. Despite the limitations in their understanding of chemistry, this emphasis on experimentation led to a surge of scientific discoveries in Europe. Alchemists like Tycho Brahe, Isaac Newton, Robert Boyle, and Francis Bacon revolutionized science. Modern chemistry. Though the Greeks had suggested the idea of atoms centuries before, it wasn't until the middle of the 1600s that this view of matter began to gain some acceptance. This led to an explosion in the development of chemistry. It was during this boom in science that people began using quinine to treat malaria. Elements were redefined and chemists began producing them in the lab. By 1800, chemistry had become an academic discipline. In America, several colleges made chemistry a part of their curriculum. Benjamin Rush of the College of Philadelphia was the first professor of chemistry in the United States. He provided the medications Lewis and Clark took on their expedition of discovery in the American West. Branches of chemistry began to develop around the world as chemists used the atomic model to interpret the results of their experiments. Practicality still drives chemistry today. People still need clothing, food, tools, and medicines to make life easier in a world full of discomfort and disease like malaria. But though we do chemistry for the same reason, we use different models to interpret what we observe about the nature of matter and the changes it undergoes. In a way, models have an effect similar to a person's worldview. Our worldview affects how we interpret the evidence and make sense of things. We'll talk more about that role of the biblical worldview in the chemistry in the next section. You need to work section 1A. Number 1 says, what reasons can you give for people to pursue discoveries in chemistry? Number 2, how does a scientist's worldview affect the way he does his science? 3, evaluate the statement, scientific models reveal what is true about the world. 4, how has human history affected the development of chemistry? Think about the places where chemistry advanced over time. 5, do an online search for history of chemistry. Use this information to create a timeline of key dates in chemistry's history. Include a few other significant dates in your timeline, such as the birth of Christ, fall of Rome, Protestant Reformation, American Revolution, Civil War, end of World War I and II, and the fall of the USSR. Number 6. Research the following fields in the chemistry and build them into the Venn diagram below. Inorganic chemistry, organic chemistry, biochemistry, nuclear chemistry, physical chemistry, and analytical chemistry. Biophysics has been done as an example for you.